Voice signaling in telecommunications. Voice signaling is the exchange of control information used to establish, manage, and terminate telephone calls. This process is distinct from the actual transmission of the user's voice, the media. Core signaling categories. Signaling techniques are generally classified into three functional categories. Supervision monitors the status of a line or circuit to detect changes like on-hook, idle, or off-hook, answering/originating a call. Addressing transmits the destination information, such as the dialed phone number, to the network switch. Alerting provides audible signals or progress tones to users, such as ringing, busy signals, or dial tones. Primary signaling methods. The industry distinguishes how signaling is delivered relative to the voice path. Channel-associated signaling, CA. The signaling information travels on the same dedicated channel as the voice payload. In-band signals, like DTMF touch tones, are sent within the same frequency band as the voice. Out-of-band signals are sent on a separate narrow frequency within the same overall channel, common in older digital T1/E1 systems. Common channel signaling, CCS. A separate, dedicated data link is used to carry signaling for a large group of voice channels. This allows for much faster call setup and more advanced features like caller ID. Modern protocols, 2026 standards. As of 2026, the telecom landscape is heavily dominated by IP-based signaling, though legacy systems remain for interoperability. SIP, Session Initiation Protocol. The current industry standard for VoIP, 5G, Voice over NR, and cloud-based communication systems. It is highly flexible, supporting multimedia sessions beyond just voice. SS7, Signaling System Number 7. A legacy CCS protocol still widely used for connecting different carrier networks and supporting older 2G/3G services. Diameter, the primary signaling protocol for 4G and 5G authentication, authorization, and charging. Voice AI and security. In 2026, signaling is increasingly integrated with AI verification to detect deepfake audio and prevent fraud, as messaging and voice verification converge. Analog voice signaling. Analog voice signaling in traditional telephony refers to the use of continuous electrical variations to manage call states and transmit destination data. These signals operate in the voice frequency, VF, band, typically restricted to a range of 300 Hz to 3400 Hz to ensure intelligibility while filtering out noise. 1. Supervisory signaling, line status. Supervisory signaling monitors whether a line is idle or in use by detecting changes in electrical current or grounding. Loop start, the most common method for residential lines. When a user lifts the handset, off hook, it closes a physical circuit loop, allowing DC current to flow from the central office, CO. This current flow signals the network to provide a dial tone. Ground start, primarily used in business systems, PBXs, to prevent glare, when an incoming and outgoing call occur simultaneously on the same line. It requires grounding one of the wires, typically the ring wire, momentarily to request a dial tone. ENM, ear and mouth. A legacy trunking interface used to connect switches. It uses dedicated E and M leads separate from the voice path to handle signaling. 2. Address signaling, dialing. This transmits the dialed number to the network switch. Pulse dialing, rotary and older mechanical method that sends a series of electrical clicks by rapidly opening and closing the circuit loop. For example, dialing a 3 sends 3 pulses. It is slow and no longer actively used in modern networks. DTMF, dual tone multi-frequency known as touch tone. It is the standard for 2026. Pressing a key generates a unique sound made of 2 simultaneous frequencies, one high, one low. It is significantly faster and more reliable than pulse dialing. 3. Alerting signals, tones. These are audible signals sent back to the user to indicate the call's progress. Dial tone indicates the network is ready to receive digits. Ringing signal, a high voltage AC signal, typically 90 V, sent to vibrate the bell or trigger the electronic ringer of the destination phone. Busy/reorder tones indicate the destination is in use or the network is congested. Advantages and disadvantages. Feature analog signaling. Pros: high simplicity, low cost for short distances, and natural sound quality without quantization errors. Cons: highly susceptible to noise/interference, signal degradation over long distances, and very limited bandwidth. Loop start. Loop start is a supervisory signaling protocol primarily used for subscriber-to-switch connections, example a home phone to a central office, to manage the beginning and ending of a call. It relies on the presence or absence of electrical current on a 2-wire circuit, known as the tip and ring lines. Electrical mechanism. Idle state, on hook the circuit is open, and no current flows. The central office, CO, maintains a constant DC voltage, typically -48 V, on the ring line while the tip line is grounded. Seizing the line, off hook lifting the handset closes a switch hook inside the telephone, completing the circuit between tip and ring. Current then flows through the local loop, which the CO switch detects to initiate the dial tone. Alerting, incoming call to signal an incoming call, The CO superimposes a high voltage AC signal, typically 90 V at 20 Hz, over the existing DC voltage to trigger the telephone's ringer. Key operational characteristics: simplicity and cost. Loop start is the most cost-effective analog signaling method because it does not require complex ground references or sophisticated equipment. Polarity insensitivity. In most modern implementations, the tip and ring wires can be reversed during installation without affecting the system's ability to seize the line. Limitations and risks. Glare. This occurs when an outgoing call is attempted at the exact moment an incoming call arrives. Because the phone is only notified of an incoming call during the ringing phase, it may attempt to seize a line that is already busy, leading to misconnected calls. Lack of far-end disconnect supervision. Standard loop start does not automatically inform the caller when the other party has hung up. The line may remain open until the local user also hangs up, or until the CO provides a busy tone that a modern device, like a PBX or voice gateway, must then detect and clear manually. Cool start extension. To address disconnect issues, an extension called Cool Start, or Open Loop Disconnect, is used in 2026. It briefly drops the loop voltage to signal a disconnect to connected equipment. Ground start. Ground start signaling is a specialized analog supervisory technique primarily used on high-volume business trunks, such as those connecting a private branch exchange, PBX, to a central office, CO. Unlike standard loop start, it requires a handshake involving a ground connection before a call can be established, providing a more robust way to manage busy lines. Why ground start is used. Background. Ground start was developed to solve critical flaws in the simpler loop start protocol that become apparent in high-traffic business environments, eliminating glare. Call collision. Glare occurs when a user attempts to make an outgoing call at the exact moment an incoming call arrives. In loop start, the PBX only knows a line is busy once it hears ringing, which has long silent intervals, cadence. Ground start forces the CO to ground a tip lead immediately upon receiving an incoming call. The PBX can sense this ground instantly and will not attempt to use that line for an outgoing call, effectively preventing collisions. Far-end disconnect supervision. Standard loop start often fails to notify a PBX when the remote party hangs up, leading to stuck lines. Ground start provides positive disconnect signaling. When the CO or remote party disconnects, the CO opens the tip lead, which the PBX senses immediately to clear the line. Faster dialing. Ground start provides a positive signal, tip ground, to the PBX indicating that the CO is ready to receive digits. This allows the PBX to begin dialing immediately rather than waiting for a pre-programmed pause timer, which can sometimes be too short and result in misdialed numbers. How ground start works. Mechanism. Ground start uses the same two wires, tip and ring, as loop start but manages them differently during the idle and seizure states. One idle state, the CO leaves the tip lead open, not connected to anything, while keeping -48 VDC on the ring lead. 2 PBX initiates. Outgoing call. The PBX momentarily grounds the ring lead. The CO senses this ground, attaches a digit receiver, and then grounds the tip lead as a confirmation. The PBX senses the tip ground, closes the loop between tip and ring, and removes its ground from the ring lead. 3 CO initiates. Incoming call. The CO grounds the tip lead first to signal the line is busy to the PBX. The CO then applies the standard AC ringing voltage to the ring lead. The PBX detects the tip ground and prepares to answer the incoming call. Key requirements. Common earth ground. For ground start to function, both the CO and the PBX must share a common reference to earth ground. No polarity reversal. Unlike loop start, where tip and ring can often be swapped, ground start circuits must maintain correct